In this segment, we'll discuss about the different operations performed on signals. Now, as far as a signal is considered, there are two important characteristics that can be changed. One is time period and other one is amplitude. So based on the characteristics, maybe amplitude or maybe time period, we are going to perform 6 different operations, including time shifting, time reversal, time scaling operation. Then we'll discuss about amplitude scaling operation, followed by addition of signals and multiplication of signals. Now here we'll take an overlook on time shifting operation. The name itself indicates there should be a shift on x-axis, that is time. How can we accomplish this? So time shifting operation can be accomplished by shifting an input signal x of t by a certain delay. Let us consider the certain delay as t, such that the output signal will get y of t becomes equals to x of t minus capital T, where t is the fundamental period with which we are shifting the signal. Now, considering this time period, we can have two different values of t. The first possibility I am writing, if t is positive, so this kind of operations are called as right shift operations. Similarly, if the time period is negative, it is known as left shift operation. Let us consider this with the help of an example. Let us assume that we have an input signal which is given in a form like this. It is basically a rectangular function ranging from -1 to +1. Here I am putting this t and let this is x of t. Now I am writing both the possibilities. The first possibility is we are expecting an input signal y of t or output signal y of t, which is obtained by shifting input signal by 2 units, and the second possibility as y of t is equal to x of t plus 2. Now let us take this one particular example. Now whenever we will get such kind of examples, always try to compare this with respect to 0, so that the time period will get as +2. That means we have to add +2 delay or +2 time period to the input signal. Let us start. Here the range is -1 to 0, so I can add -1 plus 2, that is going to be 1. That means a new signal will definitely start from 1. Let us add this 0 with 2. 0 plus 2 is going to be 2. Similarly, the upper limit 1 plus 2 will be 3. Now this entire range has an amplitude 1, so that remains same for the range 1 to 3. Here it is amplitude as 1. I will put this amplitude as 1. Now if you compare this signal, here the signal was starting from -1, it is starting from +1. That means it is shifted up by 2 units and it is shifted towards right side, and such kind of operations are called as right shift operations. Similarly, if I take this particular example, I am equating this t plus 2 as 0, will get t is equals to -2. We have to add -2 to the input signal. So let us start with this. -1 minus 2, it will be -3. Then 0 minus 2, it will be -2, and this is 1 minus 2 is going to be -1. Our reference axis 0 as it is. Now in this particular range, the amplitude is 1. Now if you compare this signal was initiating from -1, now it is initiating from -3. That means it is shifted towards left side, hence this operation is called as left shift operation. Now one more terminology is there. Right shift operations are also called as delay, and left shifts are also called as advanced. Now why delay? Because here the output signal is starting from 1, but in previous case it was starting from -1. So there is a delay of 2 units. It is started with late, whereas in this case it was supposed to start from -1, now it is starting from -3, so there is an advancement. So right shift operations are called as delay operations and left shifts are called as advanced operation. Similar function we can accommodate for discrete time signal also. I can write y of n is equal to x of n minus k, where k can be any value. Again, it has two possibilities. It can be positive, it can be negative. So based on that, we can accomplish the first operation, that is called as time shifting operation. Now if it is a time shifting operation, we will come across the second operation, that is called as time reversal operation. Now how can you accomplish? The statement itself indicates time should be reversed. That means if I am assuming that I have an input signal as x of t, its time reversed definitely x of minus t. That means if I fold input signal about t is equals to 0, we will get what? X of minus t, or simply we can say that replacing t with minus t will get the time reversal operation. So I can write the output signal y of t is equal to x of t or x of minus t. Similarly, for discrete time signal, I can write y of n is equal to x of minus. Let us understand this with one example. Let us assume that we have again an input signal. Suppose this is our input signal. Here it is 0 to 1 range and this is 1 to 2. Now we will put their amplitude terms also. In between 0 to 1, we will assume that the amplitude is 1, and in between 1 to 2, let us consider the amplitude is 2. Now if you are getting this as our input signal, is going to be x of t. Now in this case, we will replace positive values of t by minus t, so that I can sketch the time reversed signal. Here I am drawing it. We will fold about t is equals to 0, so all positive value becomes negative, negative becomes positive. Remember, amplitude will not be changed, only the time scaling parameter is going to be changed. So here I am putting the reference axis as it is. Let us start with the range from 0 to 1. Now this is 0 to 1 positive, it becomes 0 to minus 1. So this is 0, this is minus 1. Now in case of 0 to 1, we have an amplitude 1 that remains same for 0 to minus 1. Now let us come across the next range, 1 to 2, it becomes minus 1 to minus 2. In this range, we have an amplitude 2, so here it will rise and it remains 2 until it reaches minus 2. And this is 2, this is 1, this will be our x of minus t, this is t. That means folding the input signal about t is equals to 0, we will get time reversed function. Similarly, we will take an example for discrete time signal also. Let us assume that we have an input discrete time signal. Let for 0 the amplitude is 1, for plus 1 the amplitude is 2, for 2 the amplitude is minus 1, and we will consider one more sample. Suppose for minus 1 the amplitude is 1, this is n, and this is our input discrete time signal as x of n. Now we have to perform time reversal operation. So just replacing or folding about n is equals to 0, we will get positive to negative, negative to positive. I am keeping the reference term as it is. Here for 0 the amplitude is 1. Now this plus 1 becomes minus 1, amplitude for 1 is 2, now it becomes for minus 1, and amplitude is 2. For 2 it was minus 1, now it represents for minus 2, the amplitude will be minus 1, and for minus 1 it was 1, it becomes for plus 1. This is our time reversed signal as x of minus n. Now we'll move on to the third property which is called as time scaling operation, or we can call it as time scaling property also. Now here it simply indicates we have to scale the x-axis parameter as time. Now scaling will have two different results. Either it will be increased or it will be decreased. That means the x-axis parameter can have an increment of value or the values can be decreased. So we can accomplish time scaling operation. I am just putting the statement as time scaling operation of an input signal x of t can be accomplished by replacing x of t by x of beta t, or simply replacing t by beta t, where this beta is called as time scaling factor. Now if it is beta, or it can have two different values, it can be in integer or it can be in fraction. So based on that, if beta is integer, the signal will be compressed. We'll see how it is compressed. And if beta is fraction, or it is in fraction, our signal will be expanded. That means there are two operations, compression and expansion. Now how we can say that it is compressed or expanded? Let us see with one example. For that case, let us assume we have a sketch like this. This is from 0 to 2 and this is from 0 to minus 2. I am simply assuming we can take any of the input terms. This is t and this is input signal as x of t. Now let us consider that we got an output signal y of t, which is equal to x of, let's suppose it is 3 times t. That means here the input signal is time scaled by a factor of what? 3. Now whenever it is time scaled by a factor of 3, we have to do only one thing, is just divide the input signal time period parameters by the given beta factor. That means here it is minus 2, so we have to simply divide minus 2 by 3. So we will get this particular term as minus 2 by 3. Next 0 by anything is 0. This is 2 by 3. And the amplitude again remains same. Here it is. This is 1, this is 2, and this is our output signal as x of t. Now if we compare the output signal with the input signal, here the range is from minus 2 to plus 2. Now it is from minus 2 by 3. That means minus 0.66 to plus 0.66. That means our signal is compressed. That means whenever beta is an integer or it is an integer, the signal is going to be compressed. Whereas if I consider y of t is equals to, let's suppose it is given as 1 by 3t. 1 by 3, definitely it is in fraction 0.33. Now what we have to do? Just divide the time period parameters by the factor. So we will get this particular signal. Again divide minus 2 divided by 1 by 3. So this 3 will go in the numerator and we will get minus 6. So now it will start from minus 6, 0 as it is, and 2 again divided by 1 by 3 is going to be plus 6. So in that range our amplitude is same. So from this range amplitude is 1, and for this particular range amplitude is 2. Now you can see our signal is expanded. So based on that we can say that it can be compressed or it can be expanded. Similar term we can adapt for discrete time signal also. In this tutorial we will just try to define what are the different operations, and in next couple of videos we will see variety of examples on time scaling, time reversal and other operations. Now we will move on to the next operation, that is going to be addition of signals. Now here it simply defines addition of signals, we require minimum 2 signals. Let us assume that we have 2 signals, input signals, x1 of t and x2 of t. So the addition will result into an output signal which I am writing as y of t is equal to x1 of t plus x2 of t. Now how can we add this signal? So whenever we are adding the signal, only the addition of amplitude takes place and the time period remains same. Okay, so let us assume again with one more example. Let us suppose we have the first input signal which is given as, say, 0, this is 1, this is 2, here the amplitude is 1. We'll treat this as first input signal x1 of t. Similarly, I am considering the second input signal, which is, suppose, it's given like this, minus 1 to 0, 0 to 1, 1 to 2. This amplitude is 1, this is 2, and this is our second input signal as x2. Now let us add this term. Now whenever we are adding 2 or multiple signals with each other, always start from the minimum location values or minimum terms. So if I compare both these terms, here it is starting from minus 1 to 0, this is the range. So in case of minus 1 to 0, we have an amplitude of 1 here, and here it is 0. So 0 plus 1 is going to be 1. That means in case of output signal in the range minus 1 to 0, the amplitude is 1. Next, 0 to 1, here the amplitude is 1, and 0 to 1, here also the amplitude is 1. So 1 plus 1 is going to be 2. That means for the range 0 to 1, it will rise and it will have an amplitude 2. Next, 1 to 2, here the amplitude is 1, and here if you look at 1 to 2, this portion, the amplitude is 2. So 1 plus 2 is going to be 3. That means here up to this, the amplitude is what, 2. Now it will rise as 3 and it remains 3 until it reaches 2. So this is going to be the addition of signal. That is for continuous time signal. So from that we can conclude one thing. In case of addition of signal, amplitude will change, time period will remain unchanged. That means amplitude changes. This is it. This is for continuous. Let us take one example fastly. We have discrete time signal for 0, 1, 1, 2. 2 is having amplitude minus 1. I am assuming this is x1 of n. We have second signal for 0, this is 2. For minus 1, it is having amplitude minus 1. 1 is having amplitude 1. Suppose 2 is having amplitude again as minus 1. Now we have to add these two signals. Remember, in case of continuous time signal, we have to take the range because they are continuous in nature. In case of discrete, we have to take the sample. So let us start with the minimum sample. This is minus 1. Here it is minus 1. Here it is not defined. That means amplitude is 0. So add 0 with minus 1. We'll get for minus 1, the amplitude is minus 1. For 0, here it is 1. Here it is 2. So 1 plus 2 is going to be 3. There similarly 2 plus 1 is going to be 3, and for 2 minus 1 it will be minus 2. So this is going to be our output signal as y of n. Now if it is an addition of signal, similarly we can go for its respective part as multiplication. In case of addition, we have added the two signals. Now we have to multiply. Multiplication of only amplitudes. So we'll get y of t is equal to x1 of t into x2 of t, and for discrete, y of n as x1 of n into x2 of n. Now let us multiply. Same example. Okay. So if you see for minus 1, here the amplitude is minus 1. Here it is not defined, so amplitude is 0. 0 into minus 1, definitely 0. That means in case of this, we'll get for minus 1, the amplitude is 0. Next for 0, here the amplitude is 2, here it is 1. 1 into 2 is going to be 2. that means for 0 the amplitude is 2. Similarly for 1, here it is 2, here it is 1. 2 into 1 is going to be 2. So for 1 amplitude is 2. Next for 2, in both the cases the amplitude is minus 1, minus 1. So minus 1 into minus 1 is going to be plus 1. So we'll get for 2 the amplitude is 1. And this is our output signal as y. So this is known as multiplication of the signals. Now once the multiplication is over, we'll move on to the next and the last property, that is called as amplitude scaling property. Now the statement is simple. Amplitude scaling of a signal can be accomplished by multiplying every signal with a factor a. That means if we have an input signal x of t, if it is multiplied with a, that is amplitude scaling factor, this operation is known as amplitude scaling operation. Time scaling factor में हमने क्या किया था, we have expanded or compressed the signal. In case of amplitude scaling, amplitude increase हो जाएगा या फिर वो decrease भी हो सकता है. That terms we can again call as amplification or attenuation. Let us see this with one example. Let's suppose we have a sine function. I am assuming only this one. This. Let's suppose this amplitude is 2, this is minus 2, this is t, and this is x of t. Now, if I am multiplying this input signal by a factor say 0.5, what will happen? We have to multiply the individual amplitude term with 0.5. So let us start. 2 into 0.5 is going to be 1. That means now our signal level will be decreased from 2 to 1 and minus 2 to minus 1. And the shape will remain same. Probably it will have a shape like this one. So if the amplitude is decreased, this operation is known as attenuation. Similarly, if you consider y of t is equals to 2 times x of t, that means we have to multiply by factor 2. So 2 into 2 is 4, minus 2 into 2 is going to be minus 4. That means now the signal strength will be boosted. Probably we can get a sketch like this, plus 4, minus 4. So here this is known as amplification. So we can get both the terms. It can be amplified signal or attenuated. So such kind of operations are called as amplitude scaling operation. Now the same operation we can even perform for discrete time signal. The same term, amplitude को बढ़ाओ या फिर उसको decrease करो. So these are the set of operations that we can perform on a signal. I hope you understood these operations. So in next lecture we will see examples based on operations on signals. Thank you.